Hello guys, um, it's me again. So now we're gonna cover DC interconnected calculations. We're still under topic AC and DC distribution system. Now we're gonna cover DC interconnected, interconnected calculations. Right? Again, have this thing copied somewhere because you might get lost as we go. Right? I have the hard copy here, so I'm not gonna keep viewing this thing. I'm closing it now. So yeah. So what I did, okay, we are still using our ETG notes, all right, and we now on example number 2. Let me read the example for you. It says from example 1, meaning we're going to use the same circuit. That is why I have the same circuit there. It's the same circuit that we had on the previous video, as well as the load voltages, right? Cool, let me read this. It says from example 1, determine the voltage at each load point. One point A and C are linked with an interconnector having a resistance of 0.4. That's 21 marks. Cool. Let me make sure it's on flat mode. Okay, cool. Now the only difference now between today's circuit and yesterday's circuit is that we now have an interconnector connected there with a resistance of 0.4 ohms. Right? Cool. So the first thing that you're going to have to do is to find the VThevenin. Remember from electrical, I think that's electrical 2, when we were calculating VThevenin, we would remove or pretend that the point that we're actually interested in is quon. So that's why I'm removing the interconnector. It's just for the purpose of finding the VThevenin. Instead, we're going to place our voltmeter. We're going to put our voltmeter there. Cool. So VAC, you see, is just VA minus VC, right? And remember, VC is 450,507. Okay, cool. Now let's go ahead and calculate it. That is very simple. VThevenin is equals to VA minus VC. That is 480 minus 450,507. And the answer is 480 minus 450,507. That gives us 29,493 volts. This is the VThevenin, right? Sharp. So after that, we have to find the Thevenin resistance. I'm gonna remove the V there, this V, instead put our ohmmeter there, right? So looking at the way the circuit is structured, we can see that RAB, RAB and RBC, they're in series, right? If you put your voltmeter where we just put ours, right? And then RAD is in series with RDC. And then the solution, meaning your top section is in parallel with the bottom section is in parallel with the top section. That's what we're gonna do now. I'm gonna put it down what I just said. I said VThevenin is equals to the top resistance, that is VAB, plus RAB. Why am I keep saying B? And RBC. The solution is in parallel with RBC. Is it? No, it's not BC. It's not BC. It's CD. RCD plus RDA. Cool. Or maybe I should change, because I remember someone asked me how do we punch this thing on a calculator. Well, we don't have that on a calculator. That is simply okay. Let me put it. Let me do it the right way. Let me do it the right way. Let me call the top section thingy resistance R top, right? It's simply RAB in series with RBC, and that is 0,1008 plus 0,252. The answer should be 0,3528 ohms. let me make sure 0,1008 plus 0,5. Oh yeah. Nah. Now we're gonna have the R bottom. I keep saying V, please excuse me, but I know you see what I'm doing, so just bear with me. R bottom just gonna be R bot, that is now RAD in series with RDC, right? That is 0,2016 plus 0,1848. Yeah, they didn't come out of my head, they are right there. You see we have 0,1008, 0,252, 0,2016, 0,1848, right? Sharp. So now that gives us 0,2016 plus 0,1848. That's 0,3864 ohms. Now R7N rather. R7N is equals to the R total. Meaning if you add them together, I just showed you that they're in parallel. So I'm gonna use the product sum, right? We're gonna have R top. Where are we? Okay. We're gonna have R top times R bottom all over. This is not top. What is this? Right, over R top now plus R bottom. I'm not gonna substitute the value, just you will do it on your own, but it's gonna give us, let me see, pre-answer. Okay, pre-answer plus times answer over pre-answer plus answer is 0,1844. I don't know if you will confirm from your side, but it says 0,1844 ohms. Sharp. So now we have V7N, we have R7N. I'm gonna remove the calculation step thingies. I need space, right? And I'm gonna move all of this, just just have it there. Cool. So now we need the current now. Our next step is finding the current. We're gonna have to first start by calculating the I7N. I7N is also equals to the interconnector current, or IAC, right? Oh god. I7N, which is also IAC, is simply V7N over R7N plus something. Let me show you why. Remember, all along we ignored the interconnector, or rather we pretended that it was not there. So now we are putting it back. Yes, we are putting it back. I didn't make up the rules, guys. That's how it is. To find the R7N as well as the V7N, you just put your meters at your point of interest, and then when you find the current, now you put your component back. I would explain with what is this the resistance. Remember, to find the resistance of the circuit, we kill the resistance, or we don't feed it with anything, right? We find in the resistance. As for the voltage, I can explain for that, but then remember, to find the current, we definitely need to give it something. We need to power it. So meaning we're gonna need to put back our component is 0,4 ohms. Cool. So we're gonna add it with that resistance. So let me call it RAC. So our V7N is 29. Let me make life easy. I mean, we have these things now. Cool. Copy. Is equals to paste. Where did you go? There you are. All over. That is 0,1844 plus 0,4. Just gonna punch that in on my calculator as it is to avoid taking too much space. 0,1844 plus 0,4. So our first current is 50. That's 50, let me say 467 amps. This is IAC, which is also known as I Thevenin. Right? So I'm just gonna remove the Thevenin surname and just leave it as IAC, because that's what I'm interested in. Right? Cool. So I'm gonna pause this video and then clean up a bit. Okay, hi again. So now we have the IAC, right? Let's just give it a direction there. Let's say it moves from A to C. I mean, it only makes sense, right? Cool. So now we're gonna calculate our currents now. Again, applying Kirchhoff's current law, right? Starting with, let's start with DC. You can start with any current actually, right? So I'm just, or maybe let's start with AB. Let's start from AB and let's follow the right route. No, guys, should we? Let me pause this video and just look at the easiest way of doing it. Okay, I'm gonna have to refresh again. Oh, I keep saying things that I can't account for. We have to find the voltages before we get to the current. I'm sorry. Okay, so you see now we have voltage AB going to that direction, and then voltage BC going to that direction, voltage AC is going to that direction. I mean, this is clockwise, and then we have counterclockwise this side. They're opposing each other, right? Actually, yes, we can add AB and BC together, but then we're gonna have to subtract with AC because they are going to different directions, right? So let's do exactly that. VAB plus VBC minus VAC equals to 0. This is Kirchhoff's voltage law, right? So again, another trick. Okay, the same trick that we used previously. We want to represent our currents in terms of just one current. So we're gonna use IAB. I hope they use the same AB on the slides. I'm trying to make you understand the notes, right? You can make up things on your own. Maybe present them with BC or something. I just hope. Okay, I'll check later. Anyway, VAB is simply IAB RAB plus R. You see now IBC. Okay, let me do it. IBC RBC minus IAC RAC all equals to 0. Good. So I want to talk about IBC. IBC, applying Kirchhoff's current law, is simply AB minus IB. Why do I say that? Let me show you again. We have a node which is the bus bar, right? And then IBC is headed to that direction, and then IAB now is entering the point, but IC is leaving the point. The sum of currents entering the point is equals to sum of current leaving the point, right? Meaning IAB is equals to B plus BC. So now we are looking for BC. We're gonna transpose B to that side. So now we have AB minus B is equals to BC. I hope you see it. I know you do. Hi, bro. Chin. Good. Meaning here we're still gonna have AB, right? So we're gonna have AB, RAB. I'll substitute the values later. Plus, now instead of IBC, we're gonna have IAB minus our IB is 74. Then we still gonna have RBC minus, we would represent IAC with in terms of AB, but then because we have the value, which is gonna somehow punch it in, man. Yeah, that's 50. Consistency, champ. Consistency. IAB. I'm not AB. AC. RAC. All results to 0. Good. So now we can plug in values, right? We don't have AB, so it's simply 0,1008 IAB plus, I'm breaking the bracket and substituting the value of RBC at the same time. I'm trying to save time. Now RBC is 0,252, meaning we're gonna have 0,25. Oh, my 5 was automatic. AB minus, now it's still 0,252 times 74. That is minus 18,6. 18,648 minus, now we have our value of AB, that is 50, what is it? Where are we? It's 50,467 times, I'm out of space. I'm gonna put it here. Times 0,1. No. Times 0,4. Times 0,4. All results to 0. Right? Sharp. So let me add the like terms, no, because I see them. So 0,18. 0,1008 plus 0,252. That's 0,3528 IAB, right? And then we still have minus 18,648. Now we're gonna minus, let's see, 50,467 times 0,4. That's minus 20,187. All goes out to 0. So we also have like terms here, so I'm gonna add them and some I'll take them that side. Klar. Ne? That plus 18,648. That's 38. That's 38. So we still have 0,3528 IAB is equals to 38,8348. So to find AB, we're simply going to divide by the coefficient of AB, meaning IAB is equal to answer divided by 0,3528. That is 110,076 amps. So we have IAB, we have IAC. Sharp. Remember what we said BC is. We said BC is A minus C. We said BC is AB minus C. So let's go ahead and calculate it. IBC is equals to, IAB is now 110,076 minus 74. So I'm just gonna minus 74 there, and then we get our AC as 36,076 amps. Right, cool. So we also now have this current here. So current BC, current AC, current DC are entering the point, and current C is leaving that point. That means the sum of this equals to this. Now we have this, we have that, we have that, we don't have this, meaning we're simply gonna say this is equals to this minus this minus this. I know you can do it. I know you saw what I did. So we don't have space. IDC is equals to IC minus IBC minus IAC. IC kan ik gebruiken is 96 minus IBC is 36,076, and then IAC is 50,467. So our IDC, that is 96 minus 36,076 minus 50, I think is 467. That gives us 9,457 amps. So we also now have this. We are left with only DA, Democratic Alliance. Okay. I'm sorry, DA is entering bus bar D as ID leaves the thingy, the bus bar, and IDC is also leaving the bus bar. So meaning IAD is simply IDC plus ID. So let's go ahead and calculate it. IAD is equals to ID plus IDC. So I think this is 82, and that just gave us 9,457. So answer plus 82. Answer plus 82. We have 91,457 amps. Right? Those are the currents that you're gonna get when you calculate. But there's something wrong with the sign. I did something wrong. What did I do? I'm gonna pause the video and troubleshoot. Hello guys, you restricted or fail. Okay, I just found my problem, and I also looked at the slide and I saw that everything. This is fortunately they represented all the currents with AB. Cool. So my problem here, remember yesterday when I now manipulated the circuit for whatever. Okay, it's because we found this current as negative, and then I changed the direction. I shouldn't have done that. I'm sorry. So this is still going to that direction. I'm sorry. This affected my values. Kakulu foot. Where else did you go wrong? Here also. I remember this was also negative something. So I'm also gonna now be a good boy and put it there, right? And now remove. Do I have to? Yeah, let me do it. Let me do it just so that I don't lose people. Sharp. Now they're gone. My apologies. I'm sorry, guys. But we know the currents that we now have and not that we don't have. We have BC, we have AB, we have. Okay, let me show you why BC is not affected. BC, there is BC. Remember, we only changed the direction of this these distributors here, so they have no impact on BC, right? And again, I'm really sorry. I did something. I removed other part of the interconnector. I don't know why, but I'm gonna go on and put it back. Go back to green. Cool. So we're now again still in the process of finding DC, IDC. So IDC is leaving a point and IC is leaving a point. These are friends. IBC is entering a point, IAB is entering a point. These are friends, meaning the sum of this is equal to sum of that, sum of this. So let's go. Let me clean that up. So IDC plus ID is equals to IBC plus IAC. IDC is unknown. Okay, let me simply do this. I'm just gonna take a D to that side, right? Yeah, I'm trying to limit the use of space, and then take you, put you there, put you there. Go, go, go. Cool. And we have now that's minus ID, and take it, give it a hand, put it properly where it belongs. Here, chin. What? I am continuing, Sham. Ay. Okay, I'm sorry about that. Sometimes I lose my cool and it's not cool. Now, we have to now substitute the value of BC. Our BC is 36,076. BC is 36,076 plus AC is 50, I think is 467. Or is it 50? Yeah, it's 467. Now we're gonna minus the 96, which is ID. Why did I say D there? It's supposed to be C. So many mistakes. Is C there? I'm sorry. Well, at least I'm rectifying my mistakes. That's 96. Apologies, guys. I'm sorry. 96,076 plus 50,467 minus 96. Now, the value of IDC is equals to negative 9,457 amps. And the negative, it just shows that we got the direction wrong. So I'm not gonna do the mistake of changing the direction again. Papa oxyzing next, right? So we have that. Cool. So now we are left with this current, which is current AD. Now current AD is leaving bus bar D. Current T is also leaving the bus bar. Now current DC is entering the bus bar, meaning this and this are friends. They equal to this, right? Cool. So what are you gonna do? I'm gonna already manipulate the formula, make DA rather subject of the formula. So IDA is equals to IDC minus ID. Now the value is minus 9,457 minus 82. Minus 82 from the answer. So our value there is minus 91,457 amps. Good. You have all the currents you need. That's DA. You have now you have all the currents that you need. We just have to calculate the volts now, or rather the load voltages, right? Now looking at how this is, load voltage B is simply VA minus the voltage drop here. The voltage drop there is RAB. So I'm gonna, okay, let me do everything at once. VB is equals to VA minus VAB. Remember, VAB is RAB. Right? Cool. And then we go to VC. VC is VB minus VBC. VBC the same thing is IBC, RBC. Right, cool. Now lastly we have VD is equals to VC minus the interconnected voltage drop, that is VDC, and VDC has a component IDC, RDC. Right, so now I'm gonna pause the video to substitute the values and then come back with an answer. Hi guys, I'm back again. So yeah, I did those. I substituted the values and then I got those voltages there. Right. Yeah. So what I'm gonna do now is I'm gonna compare the two voltages and show you that the use of an interconnector reduces voltage drops. Right. So okay, actually. What happened there? Okay. And then select you. Just want to make it clean. Someone just told me to start the video from scratch. I'm not gonna do that. The fact that I lost my cool doesn't mean I'm not a good guy, right? So again, I'm sorry. Such things happen, especially when you have exam stress. I know you can relate. Paste. So a bit small. Okay, cool. So on the previous example, our load voltage B was 46,254 is now 468,9, meaning it increased. That simply means that the voltage drop on the cable AB reduced. Again, on load voltage C we had 450 and then it went up 9 plus is now 459,8 something. That means the voltage drop was reduced. And again, V load D, or load voltage at point D, was 546,71, then is now 456. I'm sorry, 456,71 is now 461,56. You see, so that means the interconnector amplifies or increases the reliability of the system, or just it makes it better. You can, yeah, I think the simplest way of saying it is that it betters the ring DC distribution system. That simply means the interconnected DC interconnected system is the better version of DC ring distribution system. Thank you guys. Please don't don't subscribe. There's not gonna be anything like this again. I don't know why this thing cut my video, but then yeah, that's it guys for this video. So next I'm only left with now AC ring distribution as well as AC interconnected distribution. I'll do those next time. If you happen to have a question and you don't have my number, because I am aware that there are people who have access or who have linked to the video and they don't even know me, or so meaning you can't ask me questions if you don't understand something on the video. Leave a comment and then I will record another video answering your question. Though honestly I don't want to do this anymore. This is not fun. I thought I was gonna enjoy recording videos, posting them on YouTube. Whoa, Sham, this is not fun. Thank you guys.